Welcome back to the Fierce Fish First Tech Challenge programming tutorial series. Our goal in this series is to provide simple and straightforward guidance in programming an FTC robot. In today's video, we are going to be creating our own PID controller, our own PID controller. So in the last video, we discussed everything about PID controllers and the underlying math behind them and what everything essentially means in them. And all of that is going to come into play in today's video. But before we do anything, we need to define a timer here. And we need to do this because this is an essential, as we learned in the last video, this is an essential part of our loops, getting the current time, or specifically integral and derivative, getting our current time and the previous time, and all of that. So this is going to look like, we're going to use the elapsed time library, and I'm just going to call it PID timer. And that's going to equal our new elapsed time, like such. So now we're done up here for now, and we'll come back to up here, you'll see why in a little bit. But right now I've just initialized the motor and done all of the things with the motor. We're waiting for start. And we're going to go into this void down here called move test motor, and this is where our PID controller is going to live inside of this void. And we are intaking the target position that we want the motor to go to. So there are a few variables we need to define. They're all going to be doubles. I'm just going to put that out there right now. They're all going to be doubles. And we need to get the error first, or we need to define the error first, so I'm just going to call it error. And that is done. We can do test motor.getCurrentPosition so that we have where we are and where we need to get to once we enter in our loop initially. And so we're also going to define our last error. I'm just going to call it last error. And right now that's going to equal 0, like such. And now, last video we talked about the PID coefficients, the ones that need to be tuned, the k to the p, k to the I, k to the d. Now we need to define those as well. So we're just going to go in order. And I'm going to set them equal to 0 right now. And as we know, these can be tuned, and we'll get a video about tuning a little later in the series. But right now, I'm just going to set them at 0. We know they're not necessarily going to be 0 going forward. And that's everything we need to do up here. But now we're going to do our while loop, which is where all of the things are going to live for our PID controller, and what we're going to keep looping over and over and over until, yeah. So we're going to go while, and we're going to want to go absolute value so we don't have to do this twice, and that's just math.abs, and that's going to be error. While that is less than or equal to, and this number here really depends on your motor tick count. If you have a higher end motor tick count, you may want to use a higher number. If you're kind of on the lower ends, then you should probably use a lower number. I'm just going to use 9 because it's my favorite number. But note that that number can be whatever we necessarily want it to be. So let's override our error again. And that's going to equal our get current position minus the target position. And that's going to be used later for our proportional loop, or our proportional part of our PID controller. And now we need to define the change in error. I'm just going to call it change in error. In like a mathematical sense, you'll see change in error with like a triangle E, or delta error. All the triangle means is change, and delta is the triangle, which means change, just to get that out there. And that's going to equal our last error minus error. Now we need to define our integral. So we're going to need to change this. I'm just going to go through with this right now, and you'll see why we need to change this. I'm going to call it integral, and that equals integral plus. So that's a little shortcut in Java here, plus equals essentially means integral equals integral plus. So I'm going to use the shortcut there. You can do whatever you want with that. And that is going to equal the change in error times our PID timer. PID timer dot time. And we notice this is in red underlined because this can't possibly exist with the plus equals because integral hasn't been originally defined. So we're going to get rid of that, and we're going to define integral as a local variable up here. And we are going to define it up here because you're probably going to have more than one PID controller for your motors, I would assume. So instead of defining it multiple times, we can just define it up here and then use it in our methods because it's always going to start at 0. And that's what the integral looks like. Now for derivative, we can just define it right in the code. And that's what we're going to do. Derivative, and that is going to equal our change in error divided by our time. Just like that. And now let's define the actual P, the I, and the D, which is the combined values that we talked about last video. So I'm just going to call it P, and that is going to equal K to the P times our error. And now our I, that is going to equal K to the I times integral. And D is going to equal K to the D times derivative. Just like that. And now we have to set our motor power. And that's just done by testmotor.setPower. We're going to go P plus I plus D. Just like that. And now we're not done yet because we need to update our last error. And we need to reset our timer. And that is basically how you create a very simple PID controller. Now there's one more adjustment we can make, and this is kind of optional. We don't necessarily need it. But say it's like crunch time and we don't have time to waste. Like we want to count how many times this loop is ran so that after it's ran after a certain amount of times, even if it's not at the target position we want it to be at, we just have to go. And at the top, we can define a new variable we're going to call repetitions. And that is going to equal 0 for now. And now we're going to go down here, and we're going to go repetitions plus plus. And what plus plus means is essentially plus 1. So it's going to keep counting the number of repetitions, and then you can add that to your while loop, like and repetitions is less than 40, or whatever you want it to be. There's actually another improvement that we can make to make it kind of easier to keep track of your coefficients and tune them easier by putting them at the top of your program in a class called PID coefficients. So there's actually a class included in FTC called PID coefficients. So we're just going to do this here, and I'm going to call them test PID. And that's going to equal our new PID coefficients, and in here you put your P, your I, and your D. Mine are all just going to be 0 for now, like I said. And then we can get rid of these here. Then we switch this to test PID dot P, and then here test PID dot I, and then test PID D. So now you can easily tune your parameters up here with your PID coefficients and then they're already in here for you to use. So that's going to be it for this video. We learned about creating our PID controller today. And from all of us here at Fierce Fish, we hope you have a great day.